Thank you. First, I just want to make sure that my slide is good. So thank you, everyone, for attending today's talk. I just wanted to briefly give credit where credit's due. I just want to acknowledge Luke Evans, who is a prior postdoc in my lab, and Alex Becker, who's a PhD student in my lab. They put a huge amount of work into the majority of the research I'll be presenting on today. I also wanted to acknowledge Southeast Climate Adaptation Science Center, so giving me the opportunity to talk with y'all today about this work, but also really important funding that they provided for this work. So jumping right in terms of the pet trade and assessing invasive species risk, I want to just zoom out a little bit and address the global trade of wildlife. The trade of wildlife, it's a global industry. It's a multi-billion-dollar industry, and it's vast in scope in terms of encompassing domestic and international trade. And a few years ago, colleagues and myself wanted to try to synthesize the sheer volume and breadth of this trade. And so we looked across resources to figure out who is in the trade, and we found it's about just over 7,000 species of vertebrates. That's about 1 in every 4 vertebrate species is in the trade in some capacity as either a pet or a product. And when I say a product, that's just whether it be meat, feathers, fur, etc. When thinking about conservation in context to the trade of wildlife, you could break it down into 2 themes. The first is thinking about native species, and here it's really about the conservation of the species in the trade, and it's focused on sustainability. And what we mean by that is if you're going to trade a species, it should pose no detriment to the species or population. And if you know, and usually we default to the cautionary principle where it's like, well, if you don't really know, or if you do know and there is evidence of detriment, then you pause the trade, reassess, etc. And a prior PhD student of mine who I co-supervised with Dave Edwards at University of Cambridge, Oscar Morden, he wanted to try to understand what happens to populations when they enter the trade. And so he synthesized, he collated across studies, synthesized several hundred populations that had pre-post trade data, and he found that the majority of populations once entering the trade show a decline in population. And so if we're just looking at that figure there, if it's to the left, it's a decline in population. And interesting enough, pet trade had the largest effect in terms of declining population. Now, on the other side is thinking about non-native species, right? So these species are being moved around outside of their native range, and this leads to invasion, non-native species establishment, excuse me. And here the focus is on the potential detriment that these non-native introductions pose to the native species. A classic example that everyone probably globally knows, especially folks here in the Southeast, is the Burmese python in South Florida. A colleague of mine, Bob McCleary, who's in my department at University of Florida, he did a really cool study where they translocated marsh rabbits to the Everglades and found that over 70% of the marsh rabbit mortalities were attributed to python mortality. So they have an enormous effect on ecosystems. Today's talk, I'm going to be focusing on this non-native species side of the equation. Now, with several thousand species in the trade, moving all around the world, there are examples of numerous introductions of these non-native species. And just a little side note I think is interesting is that not all species in the trade are wild sourced. Many of them are bred in captivity, and traits that make species good for the trade for select taxa have been found to also make them good at invading, right? So it could be behaviors that they're just good with novel conditions. They have high reproductive output, general broad diets, etc. Um, Today's talk, I'm going to be focused on risk. And when I say that, I mean current risk, but also risk when considering future conditions, future climate change. And so this is going to be applicable to new introductions, establishments. So this is a species arriving and establishing in an area, but it's also naturalized populations that could increase or expand their range beyond what is uh, current. These are often referred to as sleeper populations or sleeper species. Now, there are challenges in invasion science that have to be overcome. The 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 kind of at the highest level, when we're assessing risk at the scale of, let's say, the United States or regionally, is that risk assessments tend to rely on import data. So these are large databases of importation records. LEMIS is the most widely used one. It's overseen by the U.S. Fish and Wildlife. Some of the issues that import data have is that although they do reflect at least what species are in the trade, they don't translate well to invasion risk because they don't fully reflect local, domestic, regional market forces, right? Individuals enter, but you don't really know how many, who, where, those kinds of questions. There are limitations and biases in the data that complicate estimating ranges, populations, et cetera. These kinds of biases are, if we rely on citizen science data where they might be temporally or spatially biased, we might not know the amount of effort that was required to observe an individual of a species. Those kinds of hurdles, I guess, that we have to overcome. And then the last one is that many non-native species, especially ones that are newly arrived or newly established, are not in equilibrium with the range, meaning that the populations are still expanding or are still increasing, ranges are expanding. And so modeling, it kind of violates some of the required assumptions that need to be met in modeling a distribution. That is also complicated. And so to overcome these data limitations, we need to think about, okay, what are the tools that we have today, but then what are some new approaches that we can use to integrate data from various sources to kind of inform risk. And so today's talk, I'm going to break it up into two parts. The first part is an overall assessment of the pet trade in the United States. I think this is important because the note in that the US is the largest market of exotic pets. The exotic trade of pets is like I said, it's a multi-billion. The trade of wildlife is multi-billion-dollar industry. The pet trade is also a vibrant, prosperous industry. It's growing across the world, and so by understanding the U.S. pet trade, we kind of get insights of what might happen elsewhere as the industry grows. I'm going to provide kind of a generalizable assessment of invasion, establishment risk via the pet trade. And then I'm going to pivot to the second part, which is just an overview of an expert elicitation workshop that we held. It's focused on species of concern to the Southeast. And there, I'm going to cover some of the science of assessing risk, but I really want to provide an overview of this workshop as a template for collating information from experts in the field to assess risk. Both of these parts will be introducing some approaches that we took to overcome data limitations in invasion science. This first part, I want to acknowledge Luke Evans, who is the lead author, at least on a good amount. Not all of the work in this section is published. I'll note where it isn't published at the bottom. This work is recently accepted with some revisions still to be made in Frontiers, Ecology, and the Environment. So that will be coming out soon. I encourage you to reach out to myself or Luke if you have more specific questions about the work. So just taking a step back, let's just think about variables of establishment risk. And you can kind of break it down into two components. You have propagular pressure, which is simply individuals entering an area, right? The second is, okay, you have individuals in an area. What is the likelihood that they're going to establish a population and prosper into the future? And so if we break down the propagular pressure, I'm going to be focusing on two variables today. One is prevalence in trade, and the second is pricing. And pricing is important because it reflects the demand, right? So supply demand. If it's in high demand, short supply, it might be really high priced. But importantly, the pricing equates to likelihood of release. And I'll go into those details here a little bit more in a minute. And then the second side is this establishment success. Here we're focusing on species traits that allow it to prosper in the environment. This could be climatic suitability, habitat suitability, specific physiological traits, reproduction, etc. So focusing on prevalence in the trade and pricing, I want to first, there are kind of two archetypes here that we could kind of think about. The first is this high volume, low cost species. So this is a species that's easy to breed, right? So numbers, so it could be highly abundant if the demand is there. It's easy to take care of, and it's aesthetically pleasing. And these species tend to appeal to the novice buyer, right? And we would say that these species, the novice buyer, have the highest likelihood of release owing to them being low cost, widely available, and purchased by an unexperienced owner. The second is a high volume, high cost species. These are highly desirable. They can be difficult to rear in captivity or domestically. They can just be naturally rare in the wild, or they could have high morphological variation, which makes certain phenotypes of that species rare and in high demand. So for example, on the right side there, that's a photo from a pet expo where you can see a typical morph of a ball python in the lower left corner is $200. And in the center there, you have a very rare phenotype and it's going for $2,500, right? And so there could be wide variation in pricing owing to the rarity. But generally, these kinds of species in the trade appeal to the expert buyer, which would mean, based on price alone, low likelihood of release. If you own a $2,000 snake, you're most likely going to sell it, not let it go in South Florida. Now, invasion risk can also kind of be broken down a little bit. So you could think about risk at the species level, right? So this would be like the number of individuals in the trade, or a number of individuals of a species in the trade. Or it could be spatially explicit, and that's reflecting regional market dynamics. So an example is like, is there a culture for owning exotic pets, right, locally, right? That implies a higher risk spatially than if there is no culture at all. The other important note, the consideration is that market forces are dynamic. Right, so what is in vogue today might not be in vogue tomorrow, and so popularity of these species are ever changing. And so if we're going to kind of do a characterization of the U.S. pet trade, we have to think about what are the routes to market that these species are taking to get into the human population. We identified three. So you have your traditional pet store, right? This is your classic brick and mortar store down the road that probably everyone here is familiar with. You have exotic pet expos. These are traveling expositions, usually in metropolitan areas. You have breeders and pet stores that get together on the weekend at a convention center and sell pets. And then you have online pet stores where you have vendors selling a large array of species The online pet trade is a growing part of this industry. It's vibrant and rich with species. And so we have to kind of survey these three routes to market to really get a sense of the US pet trade. So I'm going to focus in, though, on this pet store route very briefly, because we're going to focus in on this in some downstream analyses. So why focus on the traditional pet store more than the expo or the online stores? And that's we feel that the spatial distribution of these pet stores, these brick and mortar stores, you can use them as like a workaround to inform likelihood of establishment. And it's a very simple idea. It's essentially like if you have an existing culture of pet ownership, exotic pet ownership, and you have a large number of stores present in an area, that means that there's a sufficient consumer base. And so there's obviously, like, for these stores to exist, they are selling a lot of product. And so the higher number of stores in an area equates to just a higher likelihood that individuals are entering the wild versus another area that might just have like one store and very few cells, etc. So we're going to use that logic moving forward. And focusing on these brick and mortar stores, the first question is, how are they distributed across the country? And so to address this, we pulled information on pet stores across the United States using a Google API search. And what we generally found is that high human density areas tend to have a high density of pet stores, which isn't necessarily a surprise. What's really interesting is we also identified some areas that have relatively low population density, but a lot of stores. And these are kind of unique areas, meaning that, there are kind of nuanced, there are these pet cultures, the density of people doesn't always equate perfectly with the number of stores. Now, one thing just a mental note is that we're going to revisit this pet store map and these georeferenced data in a later analysis. So now that we know where the brick and mortar stores are, we can now address this simple question of how many species are in the trade. To do this, we surveyed those three routes. We did a random selection of these brick and mortar stores, and we visited these stores to document the inventory of species. We visited pet expos across the nation, and then we also surveyed online pet stores, and we found about 1,200 species in the trade, of which about 1,000 are non-native to the US. So there is a trade of native species. You find a lot of Western species being for sale in the East, but about 1,000 are from outside of the United States, and the trade is dominated by reptiles. So 58% of the trade is comprised of reptile species. The next species group is birds, amphibians, and then mammals, and that's indicated in the pie graph there at the bottom. Now, pivoting to pricing. We wanted to think about, okay, so what is a way that we could understand the benchmark pricing for an average consumer, the novice buyer? Like, what is the number there? Is it $10 or $100 that a novice buyer would be willing to spend on a pet? And so we thought, well, we'll just create like a Petco index, we call it, which is essentially the likelihood of a novice buyer buying a pet. And these prices, using data from Petco and PetSmart, are benchmarked at an average price of about $45 and an upper price of around $250. And the idea here is that these big retail stores, they invest a lot of money in understanding supply demand. And so they understand which species have adequate supply, but then also how does this relate to consumer demand and the pricing that a novice buyer is willing to make or willing to spend for a pet? My clicker. Okay, there we go. Plotting the price by prevalence data. So we have minimum price on the x-axis, prevalence on the y-axis. The prevalence is simply of all the stores we surveyed across traditional, expos, and online. It's just how it's a proportion of those stores in which the species was present. You can see there's a large, wide variation in prevalence and pricing, and there's not a very strong correlation between the two. What is of interest here is if you look at those dashed lines, those are the benchmark pricing based on the Petco index. 24% of the species in the trade fall below the benchmark of $45, and about 60% of species fall below the benchmark, the upper benchmark of $250. Now, generally, Petco, PetSmart, they have around 20 species for sale at any given time. What this represents is that there are many species in the industry that are priced appropriately for large box stores that cater to the novice buyer. So in some ways, it means that there's a lot of potential for this industry to grow and appeal to a novice pet owner. Now, the top 10 species by prevalence in the trade, I just wanted to give you a quick overview of what those species look like. So without a doubt, the ball python is the most prevalent in the pet trade. They're everywhere. And that's, it's a relatively easy snake to take care of, but they also have incredible morphological variation. In that lower left corner, you can see just stunning, beautiful snakes there. And because of that, it means that it could appeal to many people that have different tastes, different aesthetics. And you can see in the min-max pricing at the top here, a large variation. Minimum $40 for a snake that would default to kind of the wild morphology, all the way up to $7,500, which would be a really rare gene, color combination, etc. We have crested geckos. They have a large variation from $30 to $750. Savannah monitors is in the number 10 spot. We observed a lot of these at the pet stores. I don't know why their pricing is so large. It could be owing to age and size. Now, the crested gecko is another one of these that has significant morphological variation and can really appeal to that niche buyer. So, but one of the lingering questions is does prevalence and price, do they actually equate to some indicator of propagular pressure? And I know I'm using propagular pressure loosely, and so this is simply observations in the wild. And the way we pulled these is through the early detection distribution mapping system, EDMAPS. And it's a very simple relationship. We just said, okay, based on the price and prevalence in the trade, is there any relationship with the number of observations for a given species in the wild, right? So these species got out, either they escaped or released. Is there a relationship? Now, prevalence in the trade was positively and significantly related to the number of observations in the wild, but interestingly, there was no relationship with minimum pricing. And so this is interesting because it means that market demand is occurring regardless of pricing, and this somehow is driving release. And so it's an interesting relationship, but we have to dive deeper in trying to understand some of these underlying drivers of prevalence. So we kind of covered a few angles of a few variables of propagular pressure. If we go over to the other side of the equation, establishment success. We can begin to address this simply by asking, where are the species located? Where are they from originally? Right. And so what we did here is we pulled the range maps of all the species in the trade and we mapped them out to create a species richness map. And as you can see in the red, these are the non-native species that are traded within the US. You can see that they have they're predominantly of a tropical origin, right? So the US trade is dominated by tropical species. This is of importance because there's increasing evidence in the Southeast US, for example, of increasing tropicalization of temperate systems. So we're actually seeing immigration of tropical species in our marinescapes, et cetera, where tropical species are expanding their ranges naturally and temperate systems are being colonized by tropical species, right? So this has in context of climate change, this suggests that there might be increasing suitability just based on the locality, the origin of these traded species. But we could go a little step further. So how suitable is the US in terms of climate suitability for the species in the trade? And to address this, we wanted to use a very simple approach, but a conservative approach. And what we fell on is essentially pulling a random sample of points from the native range of the species, as well as a random sample of points in the invading range, and this would be in the contiguous 48 of the lower 48 of the US, and creating a bioclimordination of temperature and precipitation variables. And then if they overlap, meaning there's climate similarity between the native and the non-native range, what we then do is we take the one standard deviation of the mean of the native range, and then we just plot any overlap that is occurring in the non-native range. And so what we're focusing in on is that little, if you can see my cursor here, this little sliver here where the invading range just intersects with one standard deviation of the mean of, in the native range. So this is a very conservative approach. We are mapping the most optimal space from the native range onto the US. And what we found is if we look on the left side, you can see current climate suitability for the species in the trade. And you can see that the most suitable areas are in the Southeast US. Now, this is a composite across all species. So this is generally speaking, the Southeast is at high risk in terms of climatic suitability, as well as large parts of Texas. But then we modeled out further to using climate change scenarios out to 2080. And you can see future suitability under climate change, and you can see much of the Southeast and even pushing into the Northeast increases in suitability. Texas becomes quite suitable, stretching up into the Midwest, and then large portions of the US Southwest, the Southwest USA become suitable as well. And again, another attempt at kind of providing some validation, as we did with the prevalence pricing. A question we might ask in regards to climate suitability is, do areas with high climate suitability also have large numbers of non-native species observed in the wild? Again, we go to EdMaps and pull records of all species with over 50 observations in the wild, and we relate that back to the underlying climate suitability. And what we found is a really nice, strongly significant relationship between observed prevalence of these species in the wild and the predicted climate suitability, right? And so this gives us some comfort in thinking that this climate suitability is a meaningful assessment of risk posed to the Southeast, Texas, et cetera. Okay, so this next section is, okay, so we've addressed prevalence pricing. and we looked at establishment success separately. Now I'd like to address the prevalence and the species traits in tandem. So we're revisiting this map of the stores that we already saw. And what we want to do, and I had mentioned in terms of spatial risk, high density of stores means that there is a sufficient population combined with a sufficient culture of pets. There's a demand. And this equates to propagal likelihood, right? So the more stores, the more cells, just by virtue of that, the higher likelihood of species being released or escaping into the wild. So what we did is we did a composite assessment of risk. So if you look at that bivariate square there, you have climate suitability on the x-axis, you have propagal likelihood on the y. And if you look at the purple, that purple indicates areas that are of high climate suitability, but also high propagal likelihood, right? There's a vibrant culture with lots of pet stores in those areas. And when we map those two metrics, which would be currently at the highest risk, considering those two metrics, you can see the Southeast US is very high risk, large portions of Texas, but then also large portions of Southwest USA. Now, interestingly, the blue areas, so that would be the upper left corner of the square there. That is an area; those are areas that are of low climate suitability today, right? So this is all current suitability, but they have high propagal likelihood. There's a vibrant pet culture in these areas. So what these areas are, they're at risk under future climate change, right? So the industry is there, right? The propagal likelihood is there. The climate just needs to change into the realm of suitability for risk to increase. And then you have areas of risk in orange. These are the areas where they're quite climatically suitable, but they're either missing the population or the culture there for pets. And so these areas are at risk under changing population dynamics, so increased populations, or in the case of already established species, it might be redistribution into these areas. So in concluding part one, we documented over 1,000 species in the trade. Large parts of the Southeast, Midwest, Southwest, these are areas of high risk under current and future climate change. And we used two validation methods showing that species prevalence as well as the composite climate suitability relate to observations of exotic pets in the wild. And what we hope is that our workflow is reproducible and easy to use. And this is important because the pet trade is dynamic in time. In order to, these risk assessments need to be performed regularly, right? Like one species is in vogue today, it could be out of vogue tomorrow, right? And so we hope this is our workflow is attractive to other folks, modify it, improve it, et cetera, so that we can do this into the future more often. All right, the next part, again, I'm going to go over, this is focused on a workshop that we held a few years ago, and it's introducing an integrative approach for trying our best at generating a robust risk assessment. I need to give credit to Luke Evans and Alex Becker again, as well as Josh Cullen, who played a huge part in this. They did a lot of the heavy lifting. And so let's just start. The Southeast is at high risk. We established that in part one. Now for this second part, I want to focus on these two variables, spatial prevalence. Now I changed it slightly, spatial prevalence in the wild. We're focusing in on specific species now within the Southeast, and we're going to combine it with establishment success, focusing on species traits. And we're hoping to do a better job with the species traits in this next section. And so what we want to do is integrate these different data streams in order to create composite assessments of risk. So the first is relative prevalence of a species. Now this is relative prevalence within the Southeast, like where are they located and at what intensity? what habitat in the area is suitable for these species, and can we do we have sufficient info? What traits can we use to model the physiological suitability, the suitability that can support activity for these species in the region? And so these are physiological tolerance limits that we can model. The workshop was comprised of 15 experts across a range of backgrounds and disciplines and expertise. We started with a list of 58. It was reduced down to 12 high priority species. The list is there on the right side. You'll notice that it's dominated by reptiles. There's a few amphibians in there, as well as one mammal, the nutria, and one bird, the Muscovy duck. Now, we're focusing on expert knowledge. This is expert elicitation. And we're trying to overcome some data limitations for these 12 species. So we want to overcome limited data in space, and we want to overcome some obstacles in estimating habitat suitability, right? The native range requirements of a species does not always align well with the non-native range of a species. And there's scattered information on physiological traits for many of these species. And as we were developing the workshop, we came to this question, like how do we actually get 15 people to provide this information effectively? So we decided we needed an interactive platform, and we needed that because we wanted to improve the efficacy and the efficiency of experts providing information, but also visualizing what information they're providing confidence around their estimates. Like they may, yeah, okay, I think it's this, but I'm not really that confident versus 100%. I know it is this. We wanted automatic reporting, right? And that was important because we needed some level of real-time reporting so that we could look at how our estimates of our risk, what do they look like, so we could interact with our participants and get their feedback to improve the data. And this allows consensus amongst everyone sitting in a room working on this app. So we decided we need to create an interactive app. Josh Collin really spearheaded this, did a wonderful job. I encourage everyone to scan that QR code, which will link you directly to the workshop website. And in this app, we basically collated expert knowledge on habitat suitability, relative prevalence of the species in the wild, and then measured their confidence in their assessment. So in terms of habitat suitability, when you go to the website, you'll come to a land use land cover map, and you're able to select your species, and then you have these suitability sliders across all these different land use land cover classifications. And the experts were able to slide back and forth across the different habitat types, whether from a range of unsuitable through to highly suitable. When they submit their response, it immediately generates a mapped suitability. They're able to review it, and then they're able to revisit and make adjustments if it doesn't seem correct to them. For the relative prevalence, they were presented with a map of the Southeast. That's the region of focus. Again, they selected their species. In this case, it would be green iguana. And then here, they're able to make some fine scale adjustments to improve their efficiency, right? So one of the things we want to avoid is this fatigue that tends to happen in workshops, especially when you're trying to collate information. So we try to make this as user-friendly as possible. Here you can adjust the opacity of that baseline raster, that yellow area. You can increase the buffer radius. So if it's a widespread species, we didn't want this small little pencil and they have to scribble it across the region. They could just create a ginormous, like an enormous little pencil circle and just boom, make the whole region prevalent. And then also the stroke hardness, which is essentially the intensity of the stroke, which is a relative prevalence from not prevalent through to highly prevalent. And after you map it, you get something that looks like this. So in those yellow areas, those are areas of high prevalence, all the way through to the magenta purple areas, which would be, yeah, prevalent, but not really. And then where there is no color, no prevalence at all. And then lastly, we wanted to know their confidence. We asked the participants to indicate their background experience, but then also provided a slider for them to, indicate their confidence in prevalence, habitat suitability. Importantly, we were able to take these bits of information and do a bias correction based on confidence in the weighted averages of suitability and spatial prevalence. The workflow, I just want to briefly just reiterate this. So we have expert data coming in. What we had a cloud storage, a local program to analyze the data real time and then generate reports. And so the collation through to the analysis is day one, and then on the second day, it was a 2-day workshop. We had reports, we had the data analyzed, and we can actually interact with the participants to review and make adjustments. And so that would look something like this. So on day 2, everyone is in the room. We went through each species, spiny or black spiny-tailed iguana, and we say, okay, these are the top habitat classifications that had the least agreement among participants. And then we say, okay, what's going on here? We'd have a general discussion, and then we would ask folks to vote. And the voting is simply having a whiteboard, and we'd say, okay, how do you feel about emergent herbaceous wetlands? Does it need to increase or decrease? What's your updated estimate? And everyone would write it down, raise their board, we'd take a photo, and now we could use that data to update some of these most uncertain categories. Right? We could do the same thing with spatial prevalence. Here is a map of the black spiny-tailed iguana prevalence at the top. We then gridded it with a numeric value in each cell. And we discussed this as a group. And then we asked folks to say, per cell, we didn't get too accurate here. We just said, would you increase the prevalence or decrease the prevalence? And again, the whole group generally provide a vote, or they're just like, this is way off. We had that a few times where it's just like, nope, not good. So, and then the last is this trait-based physiological metric. We use niche mapper, integrated many traits. In the workshop, we broke out into small groups and compiled traits across all these species. And essentially what we can do here is just generate a map of activity. And we can now take relative prevalence per species, habitat suitability, trait-based physiology, combine them, and generate a composite estimation of suitability for the region. And so if we're looking at this, you have a black and white tegu, green iguana, Burmese python on the right there. If we want to try to interpret this, the yellow areas are an interesting area. They're at risk under future changes, under future introductions. So these are physiologically suitable areas. High habitat suitability, they just aren't there yet, right? And so with range expansion or novel introductions, these areas are prime for establishment. And interesting enough, almost the entire state of Florida is yellow for the black and white tegu. The magenta pink is at risk under climate change. So if climate changes in the right direction, you can have increased risk. And then the turquoise is at risk under land use change, right? So it's physiologically tolerable. There's some spatial prevalence, but the habitat just isn't right. So what does all this mean? Kind of a summary here. The workshop was designed to be interactive, allowing for efficient data collation, analysis, and importantly, that real-time feedback, right? It was really important to generate that report and get feedback by the participants. And in the hopes is that these data aren't published yet. We're working towards that finalized manuscript, but we provided spatially explicit estimates that are really informed across different variables of importance: habitat, climate, physiology, and we hope this could lead to some targeted management decisions. So with that, I will just thank several folks that helped with some of the baseline surveys in part one. Again, Southeast Cask provided generous funding, as well as Alfred P. Sloan Foundation. If you're interested in the app, take a photo of that QR code, and I would happily take questions if there are any.